In this video, I'm going to be doing basic integration. Of course, there are some more complicated integrations that you can do, such as where you'd have to use other tools like integration by parts, or u-substitution. But as I said, this is just going to be the real basic stuff. So I'm just going to jump right into it. Here's our first example right here. And so if you recall, when we take the integral, we just do the opposite of a derivative. So instead of subtracting one from our exponent, I'm going to add one. So I have x to the power of 5 over 5 minus x to the power of 3 over 3 minus x to the power of 2 over 2, and then plus 2x. And then when you take the derivative of something, something's lost. So when we take the integral, when we go backward, we have to recall that something was lost, and we indicate that something is a c, or plus c. So this is called an indefinite integral because I don't have parameters of where I'm going to find the shaded area. So this is the answer right here. So let's do another one. I'm going to rewrite this problem. The integral of the square root of x can be written as x to the power of 1/2 plus e to the x. And then I'm going to take the integral of this, so I have x to the power, if we're going to add 1 to it, that's going to give me 3/2 over 3/2, and then plus the integral of e to the x is just e to the x, and then plus c. Now I would stop here, but I have a fraction divided by a fraction, so I'm going to just take the reciprocal, and that would give me 2/3 x to the power of 3/2 plus e to the x plus c. So that would be the answer for B. Now if we look, let's just move down. I'm going to skip around a lot. I don't want this video to be super long, so I'm going to just maybe do E. And so I want to rewrite this problem here so it's easy to integrate. So I'm going to take the integral of 1. I'm going to move all this to the numerator, so that would give me x to the power of -1, and then x to the power of -1/2, and then plus, of course. I would move this x to the numerator, but because this denominator is linear, it looks to me like this is going to be ln of x. The integral of 4 over x is going to be 4 times ln of x. So I'm just going to leave this piece alone right here. So now I'm going to take the integral of this. Well, let's combine this first. So this would give me, using our laws of exponents, this -1 is the same thing as -2 over 2. So if I add them, I'd get -3 over 2. So I have x to the power of -3 over 2. And then plus this 4 over x and dx. Now I'm going to use calculus and find the integral of these. So I'm going to add 1 to my exponent, so that would bring me down to x to the power of -1/2. Then we have to divide by -1/2, and then plus, and then this would be ln, this would be 4 times ln of x, and then plus c. Now, I am going to, again, because this is a fraction divided by fraction, I'm going to take the reciprocal. So I have -2, 2 over 1, or just 2, times x to the power of -1/2, plus 4 times ln of x plus c. And a negative exponent is not considered simplified in the United States. So if this was not the International Baccalaureate example, I would just move this back down to the denominator. I'll just go ahead and do it. I'm not going to make a habit of doing this, but you could move this down to the denominator and then write it as a square root again if you wanted to. That would be really, the same thing. All right, I'm going to move down. So this is this problem here, right? I'm going to move down and let's do A. So I'm going to zoom out so you can maybe pause and do as many of these as you want. I'm going to move into 2A, and it says integrate with respect to x. So what they're asking here is the integral of 3 times sine of x minus 2, and then integrate with respect to x. So that's going to give me, I'm going to write this down. I think that where we go from here is really helpful if we remember what we do when we have a derivative. So if my function is sine of x, then my derivative is going to be cosine of x. And if my function is cosine of x, then the derivative is going to be negative sine of x. So we're starting, since we're with integration, we're working backward. I'm going from here and I'm going back to here. So you can see if I had a sign, then I should end up, when I integrate, I should end up with a negative cosine. So that's going to give me 3 times negative cosine of x, and then minus 2x plus c. So there you go, that would be the answer for A. If we look at part C, same thing. We have, we're going to go from sine to we're going backward from our integral, our derivative of negative sine of x back to cosine of x, so that would be negative cosine of x. Then when we go from cosine to sine, that's going to give me a positive answer. So I have this negative 2 times the sine of x, and then plus the integral of e to the x is just e to the x, and then plus c. All right, let's move down to e. Again, I would encourage you to do all of these if you can, if you have time. But I'm going to just skip around. I don't want this video to be 2 hours. So I'm going to rewrite this. The divided by 3 is the same thing as multiplying by 1/3. So I'm going to distribute this. That's going to give me 1/3 x squared minus 1/3 x plus cosine of x. And so when I take the integral, I'm going to get 1/3 x cubed over 3 minus 1/3 x squared over 2. And then we have cosine of x would become sine of x. So I have plus sine of x plus c. Now, I would stop here, but I have a fraction divided by a fraction, so I'm going to rewrite this, take the reciprocal. So that's going to give me 1/9 x cubed minus 1/6 x squared plus sine of x plus c. So let's look at another one. Let's just move down to, since we're down here anyway, let's just do another problem. So I have the integral of x to the power of 1/2 minus x to the power of negative 1/2, because it's in the denominator, move it up, use the law of exponents. And then when we take the integral, we get x to the power of 3/2 over 3/2 minus x to the power of, add 1, that gives us 1/2 over 1/2, and then plus c. And then we'll do the inverse again, so that's going to give me 2/3 x to the power of 3/2 minus 2 times x to the power of 1/2 plus c. So that would give you the answer for that particular one right there. So we're good with that. Okay, moving on. I'm going to do e. I'm going to just expand this. I have the integral of 2x plus 1 times 2x plus 1. And we're going to distribute. That's going to give me 4x squared plus 2x. Distribute here and here. That's going to give us plus 2x plus 1. Combine my like terms, so I have the integral of 4x squared plus 4x plus 1. And then we're going to integrate with respect to x. And then we're just going to go ahead. I'm running out of room, so I'm going to do this up here. So my integral then is going to be 4x cubed over 3 plus 4x squared over 2 plus x plus c. I'm going to move down to, well, I would suggest again that you pause the video, do as many of these as you can. I'm going to just do a couple of these. So number 5 says, find y if our derivative, the derivative of our function is 6. So if we want to find our y value then we're just going to take the integral. To go back to our function, when we're given the derivative, we just take the integral. So I have 6 times x, and then plus c, because something was lost, right? That's my y value. Let's look at another one. How about, I'm just going to rewrite this. My derivative function is just x to the power of negative 2. So I'm going to add 1 to my exponent. That's going to give me negative 1 over negative 1, and then plus c We can clean this up a little bit to get negative 1 over x plus c, and that would be my y value. That's what y, sorry, that's my function. My function becomes negative 1 over x plus c. All right, let's look at f. So my derivative is 4x cubed plus 3x squared. So I'm going to take the integral, so that would be 4x to the power 4 over 4 plus 3 times x to the power 3 over 3 plus c. Now these cancel out nicely, leaving me with x to the power 4 plus x cubed plus c. What other problem looks fun to do? Let's do another one with ln. One of these, if you can guess, I want you to look at these, one of these is going to have ln in it. And if it's not obvious to you, I'm going to have you pause it and think about it, but the answer is C. C is going to have ln in it. And the reason why I know is because the denominator, it looks like a linear function here. So, I mean, if you tried to do, let's consider if this is 4 to the power of x, sorry, 4 times x to the power of negative 1. And if we were to try to take the integral of this, then we're going to add 1 to our exponent, so that's going to give us 4 times x to the power of 0 over our exponent of 0. Well, this is undefined. Because this is undefined, we really need to use our ln function. That would explain the ln function gives us it would give us our integral for this particular piece here of negative 4 over x. So I'm given the derivative, and I want to find the function. So I'm going to do the opposite of a derivative, or the antiderivative, which is going to give me 3 times e to the x, and then minus 4 times ln of x, and then plus c. I really should make a habit of doing absolute values here, because ln of whatever this is, whatever x was, x could have been like a negative 5, right? X could be a negative 5, but when I take that negative 5 has to be positive. So just be aware of that x has to be positive. All right, so I'm going to get into a little bit more complicated integrals. So this might be something worth looking at, where I have, if I have e to some other function, then the integral is going to be, if you recall if you take the derivative of e to the x, it's just e to the x, so it would be e to the ax plus b, and then we times it by the derivative of the inside function, which would just be a. So we do the opposite of that for integration. So instead of multiplying by a, we're going to divide by a. In fact, if you look at all of these, it's the same way. So if you look at all these, you're seeing the chain rule, but the chain rule in reverse. And so we have this ax plus b to the power of n. If we took the derivative of that, this would be a times x plus b. We subtract 1 from our exponent, and then we we multiply by this n, right? We multiply by the n. And then we just do the opposite of that. So that's why instead of, we didn't multiply by the derivative of the inside function, which would be a. So instead of multiplying by a, we're going to divide. So if you want to pause this and write it down, it'd be helpful. But one thing I want you to notice is that all of the inside functions, all inside functions are linear. If they are not linear, if you have something else like something quadratic that's inside, then you have to use a different method, such as, integration by parts or u-substitution or something else. You'll have to use another method. You cannot use these methods, the method that we're going to use right now, the inverse chain rule. You cannot use the inverse chain rule if the inside function is not linear. All right, so again, I'd suggest that you pause, do as many of these problems as you can. I'm not going to do all of them. I'm going to jump around a bit. So let's look at A. So I'm going to take the integral of the outside function, which is going to be 2x plus 5 to the power of 4 over 4. But now I have to divide by the derivative of the inside function, and the derivative of the inside function would be 2, so I'm going to divide by 2. So that's going to give me, 2x plus 5 to the power of 4 over 8, and we need to remember the plus c. So let's move on to another one. How about, let's just move on to this one here. So I'm going to rewrite this as this. So we have the integral of 3 minus 2 to the power of negative 2 dx. I'm going to take the integral of the outside function, so that would be 3 minus 2x to the power of, if I add 1, that's going to give me negative 1 over negative 1. And then we divide by the derivative of the inside function, that would be just negative 2, so negative 2. So that would give me 3 minus 2x to the power of negative 1 over negative is a positive, so that would be 2 plus c. Now if you're uncomfortable with this, you could, because we have a negative exponent that's not considered simplified, then you move all of this back down to the denominator. So you get something like, well, I'm not going to worry about it. I think that if that's something that you need to do for your class, then I would suggest that you do that. So let's do e. I'm going to rewrite this, the integral of 3x minus 4 to the power of 1/2 dx. I'm going to take the integral of the outside function, that's 3x minus 4 to the power of, I'm going to add 1, that gives us 3/2, divide by 3/2, and then we need to divide by the derivative of the inside function, which is 3, so we divide by 3, so 3. So that's going to give me, what would be that, 9/2, we take the reciprocal, so that would be 2/9 times 3x minus 4 to the power of 3/2, and then plus c. Let's look at 2a. So I want to integrate with respect to x. So again, I'm asking myself, I'm taking the integral of sine of 3x with respect to x. So sine of some function becomes negative cosine, so I have negative cosine of 3x, and then I divide by the derivative of the inside function, which is just 3, plus c. Let's look at another one. I have 2 times cosine of some inside function, so that's going to give me 2 times sine of our function, and then we divide by the derivative of the inside function, which would be negative 4, and then we take the derivative of 1, which is just going to be x, and then plus c. So if you wanted to clean this up a little bit, this 2 divided by negative 4 is going to give us negative 1/2 sine of negative 4x plus x plus c. Let's look at e. So sine, if we have our sine function, that becomes negative cosine. The integral becomes negative cosine, so I have negative 2 times cosine of 2x plus pi 6 divided by the derivative of the inside function, which would be 2. And we can clean this out. 2 divided by 2 is 1, so I have negative cosine of 2x plus pi 6 plus c. All right, let's look at another one. Let's look at, how many more do I have? A couple more sheets. So I think I need to skip around more than what I'm doing. So let's do one more on this side, and then I'll move on to another worksheet. So I have, 2 times sine of 3x, the integral is going to be negative cosine, so I have negative 2 times cosine of 3x divided by the derivative of the inside function, so that would be 3, and then plus 5 times cosine, the integral is just regular sine, of 4x, and then of course divide by the derivative of the inside function, which would be 4. So, and of course we could clean this up if we wanted to keep it from being so sloppy, but, oh, I forgot the plus c. Actually, we can't really clean it up. It looks pretty nice as it is, so I'm just going to leave it like that. All right, Now, more problems. I'm going to do, let's just jump down to 5A. All right, so I'm going to take, and again, I want to emphasize again how important it is that the inside function, that this inside function is a linear function. It has to be a linear function, otherwise you have to use a different method. So I'm going to just, let's take 3 times the derivative of the outside function, so that would be 2x minus 1 to the power of 3 over 3, and then divide by the derivative of the inside function, which is just going to be 2, so I have divide by 2, and then plus c. And then, of course, these cancel out, and that would leave me, what, 1/2 times 2x minus 1 cubed plus c. Now, if you, let's go ahead and look at one where it would be a little different. Now, I couldn't do the, in fact, let's challenge this. Let's see if we could. Let's see if we could, if we take the derivative of the outside function, so that's x squared minus x to the power of 3 over 3, and then we divide by the derivative of the inside function, which would be, what, 2x? 2x minus 1. And if that, and so is that the same thing as this here? Well, not really, because now the problem is if I wanted to go back to this, I'd have to use the quotient rule, so it becomes much more complicated. And I'm not going to do the quotient rule because it is quite lengthy, and I don't want this video to go on forever, but this is not the integral of this. So we have to do this in a different way. So in this case, I have to expand this, so I have x squared minus x times x squared minus x. We're going to distribute, and that gives us, what, x to the power of 4 minus, we have the same bases, we add our exponents so that if we're multiplying, so we have 2, we have 3, so x to the power of 3 minus x to the power of 3, and then plus x squared. And so then we combine our like terms to get x to the power of 4 minus 2 of these x cubes plus x squared, and then now we need to take the integral of this. I have x to the power of 5 over 5 minus 2x to the power of 4 over 4, and then plus x to the power of 3 over 3 plus c. And of course you can clean this up. We have negative 2 divided by 4. That could be just simplified to, to just 1/2, right? This piece here could be 1/2. So yeah, if you don't have, if the inside function, here's another one where the inside function is not linear. So you're not going to be able to use, for here, this one as well, you're not going to be able to use these simple methods that we're doing now. Here's another one as well that's going to be more complicated. You're going to actually have to expand it rather than do the integration the simpler way. So let's look at E. We have a inside function that's linear, so I'm going to just rewrite this. I have the integral of 4 times 5 minus x to the power of 1/2 dx. And so now we're just going to take the integral of the outside function. So I have 4 times 5 minus x, and then we add 1, it gives us 3/2 divided by 3/2 plus c. We can take the reciprocal of the second fraction and multiply. That would give us 8 over 3. So 8 over 3 times 5 minus x to the power of 3/2 plus c. I think I missed something. No, maybe not. Oh, yeah, I did. I forgot to take I need to divide by the integral, the derivative of the inside function. I forgot to do that. So this would be divide by -1, which means that all of this is going to be negative. So sorry about that. I missed that little piece there. So let's see. We're going to do a couple more. Again, we're going to make sure that the inside function is linear. So this inside function, well, there is no, here we have an inside function inside of our function of e, so that's linear. So we get the integral of e to the x is just e to the x, so I have 2 times e to the x, and then we have 5 times e to the 2x, that's the derivative the integral of the outside function, and we need to divide by the derivative of the inside function, which is going to be 2, so divide by 2. So that's going, and then we have to remember to add a c at the end. Let's look at c. Our inside function is linear, so the integral of the outside function is e to the power of 7 minus 3x, and then we divide by the derivative of the inside function, which is negative 3 plus e. Let's look at e. So I'm just going to, let's see, I'm going to I have a linear function in the denominator. So there should be, you should pause this for a second and figure out, you should recognize that this is a special case. The special case is that we have a linear function in the denominator, which means that the integral is going to be ln of x. So I have 5 times ln of 1 minus 3x. Now we divide by the derivative of the inside function, which is negative 3, and then plus c. So let's look at another one. Let's finish, let's do this one as our last one. So I have x. The integral of x is x squared over 2. And then it looks like it's another ln of x. We have a linear function in the denominator. So we have, minus 5 times ln of 1 minus x. And then we divide by the derivative of the inside function, which is negative 1, which then makes this a positive 1. A positive 5, sorry. So, and then plus c, of course. So there we go. All right, I hope this video was helpful, and I hope you have a wonderful day.